Hi, this is Max Liu, and this is my lab for oscillations for Physics 2211. These are the things we're going to be going over today. Here are the preview of the results. So as we can see here, the system's total change in energy remains at zero for the entire duration, indicating that the energy principle is satisfied. Uh, so a brief introduction of this lab. So the purpose of it is to analyze the x and y position of a spring mass system that's oscillating. The program tracker will be used to track the observed position, and then we will then calculate the energy changes happening in the system when in motion. These are the fundamental principles that will be used in this lab. Newton's second law describes the relationship between the force acting on the object and the result of the motion of the object. The second law is used to find the sum of all forces in the system, and in this case, it'd be the spring force and the gravitational force. And also, the Newton's second law can be used to then just derive the velocity update formula and the position update formula, which will be used in the computation. And then for the energy principle, this allows us to calculate the change in kinetic energy, the potential energy, and the change in potential spring energy as the system is in motion. So here's the tracker analysis. The system is the mass, spring, and earth, and the surrounding is nothing. So therefore, we set the change in kinetic energy and the change in this potential energy of the spring and gravity to be equal to zero. And then here's the mass of the object and the initial position found in tracker, and the initial velocity is at rest, so zero. And then these are the stretched length and the relaxed length of the spring and the spring constant, 6.83 newtons per meter. Here's the glow scoop code. So I set the ball's mass and the initial position and velocity to be ones found in tracker. And then over here, this is used to find the length of the spring, the difference of the relaxed length and uh, the stretch length minus the relaxed length. And then here we calculated the kinetic energy and the gravitational potential energy and the spring potential energy, and then sum them up to get the total energy. And then over here, we use the Newton's second law to calculate uh, the, the ball's velocity and position. And then these values are then next is we then update the spring position and the amount of stretch before and then updating this energy again. So here are the results. So similarities, the computational model roughly predicts the position to that of the observed data, though it's not as well for the Y position, as you can see here. The differences, as time goes on, the predicted position gets less and less accurate. Like as you can see here at like 5 seconds, 4.5 seconds to 5 seconds, the difference is much larger. So this indicates that other factors could affect the system. These factors could be drag, the drag force, and other possible errors. It could be human errors. So in Tracker, you had to individually plot the points to map the position of the spring mass system. So I could have not like exactly plotted the points of the center of the mass. So that could be a potential error. So what does this mean? Was the energy principle satisfied? Yes, uh, because the change in total energy was zero for the entire time. And this is due to the change in kinetic energy, the change in potential gravitational energy, and the change in potential spring energy was like all cancel each other out. So what does this mean? The oscillation estimates for x and y. Um, so I got the period of oscillations by looking at the x and y graphs and finding the peaks between each interval, and then I averaged the three time intervals. So for the x direction is 2.437, and then for the y direction is 2.944. And so as we can see here, the period of oscillation is different depending on like which direction you choose. As a result, the spring constant will be different. And if you calculate the spring force and the net force again, they would both be different. In conclusion, Newton's second law and the energy principles used in the experiment, and then the position of the oscillating spring mass system was analyzed using tracker, and the computational model was created and compared to the observed data. And then we found out in the real world there are other forces acting on the system, causing variations in the resulting graphs.